Hello, this video will focus on economic order quantity. What is EOQ, or economic order quantity? So this tells us how many to order, the quantity to order each time we order. It minimizes our holding and ordering or setup costs. It does not tell us when to order. That's going to be talked about in a separate video. We're going to talk about reorder point and safety stock there. So that will tell us when to order, and this will tell us each time we order how many do we order. So first we need to understand what our ordering costs are. Ordering costs are any labor that we use to unload a truck, to check that inventory in, to enter it into our system, to put it on the shelf, so on and so forth. The cost of any forklifts that we use to handle that, the cost of loading docks, software. A lot of times these are just totaled over the year and divided by the number of orders that were received, and you just come up with a number that is applied to each order. Costs of freight, shipping, and handling. So when you order something online, if you pay shipping and handling, that would be an ordering cost. The time of writing purchase orders, paying the invoices, so on and so forth, any of that administrative time. Again, often handled like the software and the forklifts. Maybe you have a purchasing manager whose salary is divided over the cost of all the purchases made. So when we get ordering costs, they look like this. So if we order one large order a year, we make one trip to the store, we purchase that, maybe we get one truckload in, we pay shipping and handling for one truck. That is a very low cost. Versus if every time we need something, we're buying it in very small quantities, we're buying one bag of something, one box of something at a time, versus buying an entire truckload, that gives us a much higher cost. All right, and then the opposite of that is holding costs. So our holding costs, the first two are pilferage and shrink. So this can be covered by things like shoplifting, employee theft. Shrink can also be things that fell off the shelf and got kicked underneath, are simply lost, thrown away without getting written off, kind of the just disappearing inventory. Obsolescence is most commonly referred to things like technology, or maybe magazines or newspapers. So once no one wants to read the January issue of your local paper, then becomes obsolete. Or no one wants the last year's model of a television or a laptop, right? So that becomes obsolete. Expiration. Expiration is more commonly used in food. This is things like cabbage or milk that simply starts to get old. So an iPhone from 3 models ago, it won't expire, but it'll be obsolete. Milk will not become obsolete, but it will expire. Any interest in financing involved in holding those? So if you have opportunity costs, or you're paying interest on your operating loan, that would be included in your holding costs. Your storage costs, usually calculated out on a square foot basis. These are things like heating and cooling a warehouse, paying taxes, maintaining that warehouse, a lease, any of that stuff. Handling is taking a box off the shelf to get to the box behind it. If you have a larger warehouse, you must spend more time driving around that warehouse. You have increased handling costs. And maintenance. This could be as simple as dusting a product off, or maybe it needs actually to be maintained. This is things like power sports. A lot of inventory needs to be maintained to ensure it doesn't rust, things like that. So all of these incur over time. So the longer we have something in storage, the greater all of these will start to accrue. So that line looks like this. So if we have fewer and larger orders, we have a longer holding time, we have a higher cost. If we have more and smaller orders, more frequent ordering, we get a lower cost. So then these are kind of flip sides of the same coin. So EOQ finds that balance that minimizes our order plus our holding costs. So we add our two lines together, and we come up with a total cost for our inventory here. EOQ is where the sum of these two is the lowest. So we're just adding our holding and our ordering costs, and we find this balance at EOQ. So we have a formula here, of course. So I want to point out that this is annual. Everything is annual in EOQ. This won't be true in everything that we do, but for EOQ, we always calculate it as annual. So make sure that you're multiplying any weekly demand by 52, monthly demand by 12. Same thing if I'm giving you a annual or a monthly holding cost, you have to multiply that times 12. Setup and ordering costs are always on a per order basis because shipping and handling is on a per order basis. So we've got a couple of example problems here. So we find our 2 times 720, our annual demand of energy drink, our setup costs, our ordering costs, that is $3 in shipping, and then our holding or carrying costs, 10 cents per can per year. We drop those into this formula here, and we get this answer. So, of course, for this class, don't bother rounding off, but for sake of discussion, we can say that our holding plus ordering costs are the lowest if we order 207 cans or 208 cans at each order. So let's talk about the effects of changing things. So if we reduce shipping costs to $1, is that going to be higher or lower than 208? The answer would be lower. Because we're reducing shipping costs, it now becomes more cost effective to order more frequently. So if we double the storage costs, what are the effects of this? Again, we're going to lower the economic order quantity because now our cost of holding that goes up. And what about having the storage costs? So if we have the storage costs, then it becomes more economic to order a large quantity and store them because our storage costs are lower. So 293. So then let's go through this in Excel. So you can see that I have this set up. So the function that you're going to want to use for this is the square root, SQRT. So first we can calculate all of this. So we have equals 2 times our D, our annual demand, times our S. And we can divide this by 0.1. And then we can take the square root of the entire thing. And again, we get the same answer. Now you can do this all in one function. If you so want to. Let me zoom in a little bit here so we can see what that function looks like. So we have square root 2 times our D times our S. Make sure you're using your order of operations, your brackets correctly, and there it is. All right, I will upload all of this so you can take a look.